few last words about testing from the plan and document perspective. We added a lot of stuff about the plan and document perspective recently in the book because we wanted to make sure that we're not perceived as sending the message that Agile is always the right way to do things and it's the only way to do things. So in fact, there's a lot of testing activity in plan and document. In fact, one of the criticisms of plan and document in a classroom setting is that people feel that there's so much of that they don't get to actually write any code. But we've seen that in the BDD, TDD, Agile, Extreme approach, we write the test before the code. We start from user stories. The developers are responsible for, generally speaking, for writing tests that go along with their own code. So the question is, what happens in a plan and document setting for these same tasks? Well, there's a very important role in the P&D family of approaches. Is that there's a project manager who documents the project management plan, which includes a software requirements spec, SRS. And in case you were wondering, yes, there's a standard for how you write an SRS. The standard itself is actually tens of pages. But the SRS is enormous. And the idea is that that captures the requirements. It captures the test plan. And then once you've got this overall plan, you're going to now divide the plan into programming units and essentially assign different teams to work on each unit. So teams of different developers are assigned to different units. They do their own unit testing, but when it comes to sort of putting a lot of pieces together and doing system and integration tests, there's often a separate QA team that does that. And there's different ways that the QA team can do its job. One way is you try to do top-down integration. So this is more like what we think of as user stories, where you look at the top level or the customer's view as what the app should do, and that drives you to get some of the customer-facing functionality working early on so you can start testing it. On the other hand, it means you have to do a lot of stubbing below that level so that the customer-facing things have something to do, right? It's the equivalent of doing a wireframe but with code. You could also go the other way and say, well, we're going to build out the pieces and we're going to sort of test as we go and as we put the pieces together, but that means that the customer-facing part actually might not be testable for quite some time. But in this approach, you have the benefit that you're relying a lot less on stubs, right? As we all know, the problem with relying on stubs is if the stubs get out of sync with reality, then your stubbed tests will all be passing, but the reality may turn out to be that they fail. So the downside of the second approach is it's very late in the game before you can really put the pieces together and start getting rid of the stubs. So sandwich integration tries to go from both ends, right? You sort of work downwards from the customer-facing stuff and stub where you need. You work upwards from the unit tests, and you sort of start putting modules together. And the idea is that at any given point in time, you have at least some customer-facing things that actually might talk to real app code. The rest of them are being stubbed, but they're kind of working toward each other, right? It's like digging a tunnel from both ends. So you try to get it both ways. When you're ready to do the more serious testing, you sort of turn it over to the QA team. They're the ones who are doing the system test, and at this point, they're really testing the whole app. They're also testing non-functional requirements, which we're going to talk about when we talk about operations. So things like performance. Are there performance targets they have to meet? Targets of robustness in terms of defending the data in the app against malicious attacks. And how do they know when they're done? Well, it depends on the project. In some cases, it's based on things like coverage and metrics. We saw different versions of coverage that are not only about the control paths followed, but things like define and use coverage, which talk about data production and data consumption. So have you tested all of those paths? And once the QA team has sort of signed off, now the customer gets to test it. So you can see why the Agile methodology tends to put the customer first, right? The amount of work that has happened by the time the user acceptance test comes is pretty much everything in the project, right? So the assumption is the customer is going to like it by the time it's done, right? This is the validation versus verification. Did I build the right thing as opposed to did I just build the thing right? And it may turn out that in the user acceptance test, the customer changes their mind. So again, it's not that Agile is good for all projects, and it's not that Agile does things fundamentally differently in terms of which tasks are involved compared to plan and document, but the tasks are factored into a different order, and you carve them off in small chunks. So you do use mocks, you do write unit tests, you do write integration tests, you do put the product in front of the customer, but you do that for small slices at a time, and then you come back and do another slice. As we all know, we saw very early on that testing can be used to show the presence of bugs, but never the absence of bugs. So again, what do we do when we can't do testing? Well, formal methods have been, yeah, I know, Dave made the animations for these slides. I can't take credit for the happy dancing robots. But formal methods are a completely different approach to program correctness. Basically, testing is about engineering, right? Testing is you've got this code artifact and you want to see what it does. Formal methods actually take a formal representation of the program, and they try to prove some things just based on the formal specification. For example, you might want to guarantee that it can never enter a certain state. And in fact, this is gaining traction in industry in both hardware and software. Even as late as last decade, Intel, for example, was using formal verification to model the bus protocols for their multiprocessor systems. Because what you want to do is prove that, for example, you can never have a sequence of events that results in a bus deadlock. Now, there's a big issue, which is that often the formal spec is not necessarily a thing from which you can generate program code. So you may have proven that the formal spec is correct in the sense that it never goes into these bad states, but you still have to prove that the thing that gets built also follows the formal spec, and that's a different problem. So a human might be able to do these proofs, but more commonly computers do them using theorem proving. You can also do model checking, which is a combination of symbolic execution and checking to whether what sequence of states might be reachable depending on input values and control paths. But these are pretty computationally expensive, so they tend to be used on smaller size systems, on systems that are expensive to repair because, for example, they might be out in space or they're difficult to test. Safety critical software systems are usually a good candidate for these. And just to give you some metrics, the largest project that I know about that's been formally verified is the L4 operating system kernel. That's about 10,000 lines of code, and the research effort required comes out to about $500 per line of code. NASA has managed to beat that. The space shuttle software costs about $80 per line of code per year to maintain. It doesn't change very much, and the process for changing it is extremely heavyweight, but there has never really been a software failure in the space shuttle program ever. So the methods do work if you apply them correctly. Since we're doing software that is relatively easy to change, easy to repair, and relatively easy to test, we won't be doing very much in terms of formal methods. But I would say if you're going into the software engineering field, within 5 years, you can expect these to be widely used across many companies. So kind of summing up, in the plan and document world and versus the agile world, we actually are doing all of the same things. We're creating customer specs, user stories, and so forth, but the order in which we do them is really what's different, and the teams, how the teams are factored to do them. Rather than sort of having a top-down plan and a project manager, we're doing things piece by piece and row by row.